Here we demonstrate a typical hypothesis testing procedure for analyzing syndromic hotspots. First, the user selects the syndrome of interest, in this case gastrointestinal. This generates a query to the database, and the epidemiologist can now look at the patient distribution with either an additive opacity for all patients that came in that day, a layer of red dots representing ill patients on that day, or we can choose to view the data as an aggregation. Next, we want to look for syndromic hotspots. First, we generate a kernel density estimate heat map. We see that several hotspots appear across the state. We can now look for unusual clusters of patients within these hotspots and begin forming a hypothesis about whether or not these hot areas are problematic. We choose an area of the state that appears to be problematic using our circular selection query tool. This selection then creates a time series plot of the last 90 days. We see that in this area, over that time period, there is only one alert generated for gastrointestinal syndromes, and that alert corresponds to the time period of our current map. This information further strengthens our hypothesis that there may be a health issue in this area. To strengthen our hypothesis, we now want to look at the hospitals in this area to see if they are showing any unusual events. We select the hospital nearest the area in question, and the time series plot is generated. Here we can see that no alerts are occurring at the hospital, weakening the original hypothesis. To further confirm or deny this hypothesis, we filter the data by other key symptoms. Currently, keyword filtering is not interactive. As such, we have time-lapsed our video to skip this portion. Now we want to see how many of these gastrointestinal cases also displayed signs of fever. To do this, we enter the keyword fever into our query selection tool, and the database retrieves all patients with gastrointestinal illnesses that also reported fevers. This automatically updates the time series plots for the area and hospital. Here we see that the area still shows an alert. However, we can see that this alert is generated by a single patient, as the expected value was less than 1. In such an instance, one can then assume that this alert was a false positive and move on to the next case.